Let's talk about two words I bet you use all the time: mass and weight. We kind of treat them like they're the same thing, but in the world of physics, they are fundamentally different. And I promise by the end of this, you're going to see the difference crystal clear.
Be honest, you totally have, right? We all do. When you say you want to lose weight, what are you really talking about? The amount of stuff you're made of, or the force that's pulling you down to earth? It's a super common mix up, and today we are going to get it sorted out for good.
So here's our game plan. We'll start with what mass is, then we'll bring in the force of gravity. After that, we'll see how those two things get together to create what we call weight. Then we'll put them head to head, and finally wrap it all up with one simple little formula. Let's do it. Okay, first up, what in the world is mass? Let's get right down to the foundation of everything, the unchanging stuff that you, me, and everything else is made of.
So, the official definition is that mass is a measure of the quantity of matter in an object. But what does that really mean? Well, it's just how much physical stuff is packed into something. It's the grand total of all the atoms and molecules that make you, well, you.
And here is the absolute key idea, the one thing you have to remember. Your mass is constant. It does not change no matter where you go. So if your mass is 70 kilograms here on Earth, your mass is still 70 kilograms on the moon. It's even 70 kilograms if you're just floating out in deep space. The amount of stuff you're made of just doesn't change. Here's a great little analogy to lock this in. Think of your mass like your core personality, right? It's who you are, deep down. And that doesn't just change because you go on vacation to a different country. It's a fundamental part of you. It's constant. Okay, let's bring in our second key player. So if mass is the constant stuff, then gravity is the force that acts on that stuff. It's like the great influencer of the entire universe. So get this. Every single object that has mass, from a little pebble to a huge planet like Earth, creates this invisible zone of influence all around it. That zone is called a gravitational field. It's this area in space where any other object with mass is going to feel a pull. And the rule here is actually super simple. The more mass something has, the stronger its gravitational field is going to be. That's why you're stuck firmly to the surface of the Earth and not, say, being pulled away by a passing airplane. The Earth's mass is just so much bigger. Okay, you with me? We've got mass, the constant stuff, and we've got gravity, the universal pull. So what happens when you put them together? You get weight. See, weight isn't really a thing on its own. It's the result of the relationship between mass and gravity. And there it is, the official definition. Weight is simply the measure of the gravitational force that is pulling on an object's mass. It's not the stuff itself, it's a force, a pull. This means weight is always a partnership, right? You literally cannot have weight without two things. An object has to have mass, and there has to be a gravitational field acting on it. Your weight is just the direct result of the Earth's massive gravitational field pulling on all that stuff you're made of. This is the big takeaway. This is the sentence you want to remember. Because gravity changes depending on where you are, your weight changes too. That astronaut on the moon, they have the exact same mass, the same amount of stuff in their body. But because the moon's gravity is way weaker, the pull on that mass is a lot less, and that's why their weight is so much lower. They can jump super high. Okay, we've got all the pieces. Now let's do a little head-to-head comparison to really nail down these differences. This chart pretty much says it all. Mass, it's a measure of matter. It's the same everywhere, and we measure it in kilograms. Weight, on the other hand, is a measure of gravitational force. It changes with location, and its true scientific unit is the Newton. Yeah, that's right, newtons, because it's a force, not an amount of stuff. This leads to a pretty interesting question, doesn't it? If a bathroom scale is measuring the force of gravity pulling down on you, is it really measuring your mass? And how in the world would we measure pure mass without gravity getting in the way? Well, the classic way to measure mass is with an old-school balance scale. The kind with two pans. When you put your object on one side and add known masses to the other until they're perfectly level, you're directly comparing the amount of stuff. And this works anywhere, Earth, Moon, Mars, because gravity is pulling down on both sides equally, so its effect just cancels itself out. Pretty clever. All right, let's bring it all home. All of these ideas, mass, gravity, weight, they are all beautifully connected by one single, really elegant equation. This is where it's all going to click.
First, we just need one last little piece of the puzzle, something called gravitational field strength. We just use a lowercase g for it. All this is a number that tells you exactly how strong the gravitational pull is in a certain spot. It's the force per unit of mass. And bam, here's the magic. It all comes together in this beautiful little formula, G equals W divided by M. Or, to put it another way, the strength of gravity in any given place is simply the weight it produces divided by the mass it's pulling on. So let's just break that down one more time so it's perfectly clear. G is the local strength of gravity, W is the weight, which is the force that gravity is creating, and M is the mass, that constant amount of stuff in the object. See? All perfectly connected. And here's a cool little bonus for you. That number, G, isn't just a measure of how strong the field is, it's also the exact rate at which any object will speed up if you just drop it in that field, assuming there's no air resistance. Here on Earth, that's about 9.8 meters per second every second. So let's take one final look at our cheat sheet. Mass is the quantity of matter, and it's constant. Weight is the gravitational force, and it varies. Your mass is the same on the Earth and the Moon, but you would weigh way less on the Moon. And it all connects back to that simple formula, which you can just rearrange to solve for whatever you need. W equals M times G. Simple as that. And that's really the bottom line. The next time you step on a bathroom scale, take a second to think. That scale is calibrated to take your weight, which is really just a measure of your relationship with Earth's gravity, and then do the math to estimate your mass. But now you know the real physics behind that number. You're not just seeing how much stuff you're made of. You're seeing the strength of the physical bond between you and the entire planet. Kinda cool, right?